Right, I think we're going to give people a couple more minutes to filter in after the delicious and nutritious snacks.
You want to nudge for the,
Trying to see if I can spot a likely candidate. I think pinging Alan would be bad for him. While we're waiting, if people can be sure to log in to show that they're virtually sign the blue sheet. And if we have any volunteers for note taking for the session, that would be appreciated. We won't be able to get started until we have a volunteer. And with the automated transcription or the transcription service that we have for today's session, it shouldn't be too onerous a job for capturing notes, just really any discussion, any decisions taken, etc. Do I have to go roam the hallways and get somebody to come join us? Sanjay, you would like to take notes, wouldn't you? No? Maybe. Try to go see if Sanjay will volunteer. The back on this side. Oh, or Allie. Allie could do it.
hey, Allie. You know, you'd be really great, Allie. Remember that favor I said you owe me? Would you like to be the notes taker?
We would appreciate it.
So I did a favor for Ali a little earlier, and I collected payback less than a half hour later. So. That'll also keep you from going up to the microphone and asking questions. See, thought through this.
All right. So just some preliminaries before we get going. Thank you everybody for coming. And a few notes and details, as I said earlier, please do log in or use scan the QR code in order to virtually sign the blue sheet so that we can demonstrate how many people were here. Since we are still in the COVID reality, and it is a requirement of the IETF meeting, if you are in this room, you must be wearing a mask. And if you don't want to wear a mask, that's fine, but please leave this room. So thank you everybody for doing that. I know we all enjoy it so much. Okay. I think we're about ready to roll. So thank you to Ali Began for being our note taker. I'm sure if anybody else wants to leap into the shared note-taking slides to note-taking sheet to help take the notes, that would be appreciated. And yeah, so I'm one of your co-chairs, Leslie Daigle. Kyle Rose, our other co-chair, is at home in the US and attending remotely. You can say hi, Kyle.
Hi, everyone.
And Glenn Dean, our technical advisor, is up here at front helping me with this particular session.
Hello, everyone.
Great. All right. Yes, so the usual, please do note well all the things that we must note well about the IETF processes and policies. If you are aware of any IETF contribution that is covered by patents or patent applications, You must disclose that fact or not participate in the discussion. As a participant or attendee to any IETF activity, you acknowledge that written audio, video, and photographic records of meetings may be made public. So if you're wearing a red lanyard, the photographers won't come up to you and stick a camera in your face. But if you come up to the microphone and ask a question or are presenting, do understand that you will be part of the video record. And please do observe the code of conduct. If things get, we're going to do our best to make sure that this session is civil, and we're usually pretty successful at that because y'all are very civil, a civil lot of people. But if you have any questions or concerns, please do contact the Ombuds team. And then all of the requisite documents there. Yeah, as I said, please do sign into the session. And remote participants, please make sure your audio and video are off unless you are presenting during the session. Next slide, please. I think even though it's only Monday afternoon, you're probably pretty familiar with these resources already. Great. So here's today's agenda. It is what is posted in the meeting materials, so there should be nothing surprising here. Thank you again to Ali for being our minute taker. One other point of order, I'm going to ask that everybody who wants to ask a question during the session do use the Meet Echo tool so that we can have one unified queue from remote participants and local ones as well. And any other bashes to the agenda? Not hearing any. Let's move on to the next presentation. So Renan, are you ready?
Yes, can you hear me?
Yeah, and Rita, do you want me to run the slides locally, or do you want to do it yourself?
Can you please run the slides locally?
Happy to do it. Stop sharing. Stop sharing. This is the one, right?
Yes.
Okay, so hi everyone, my name is Renan Krishna, and I will be presenting an update to our draft. This is a joint work with Akbar Rahman. Next slide, please. So the updates to the draft are as shown in the slide in section 5.1 and section 5.2. We will talk about these changes in the next few slides. Next slide, please. In section 5.1 of the draft, we have elaborated on what XR workload characteristics can be expected by network operators, their operational consequences, and some pointers to the operational strategies that can be adopted by network operators. Our use case envisages a 6 degree of freedom video or point cloud, and so will require 200 to 1000 Mbps of bandwidth. As seen from the table, the XR application, such as our use case, transmits a large amount of data per unit time as compared to traditional video applications. As a result, issues arising out of heavy tail parameters, such as long-range dependent traffic, self-similar traffic, would be experienced at time scales of milliseconds and microseconds rather than hours or seconds. Additionally, burstiness at the time scale of tens of milliseconds due to multifractal spectrum of traffic will be experienced. Now, long-range dependent traffic can have long bursts, and various traffic parameters from widely separated time can show correlation. Self-similar traffic contains bursts at a wide range of timescales, and multifractal spectrum bursts for traffic summarize the statistical distribution of local scaling exponents found in traffic trace. Next slide, please. So let us look at the operational consequences of XR traffic having characteristics such as long-range dependency, self-similarity, and multifractal spectrum burstiness. Firstly, the edge servers to which multiple XR devices are connected wirelessly could face long bursts of traffic. In addition, multifractal spectrum burstiness at the scale of milliseconds could induce jitter, contributing to motion sickness. The operators of edge servers will need to run something like a managed edge cloud service to deal with these problems. So functionalities that such a managed edge cloud service could operationally provide include dynamic placement of XR servers, mobility support, and energy management. Providing edge server support for the techniques being developed at the DetNet and RAW working groups at the IETF could guarantee performance of XR applications. Thus, the provisioning of edge servers in terms of the number of servers, the topology, where to place them, the assignment of link capacity, the number of CPUs and GPUs, should keep these factors in mind. Next slide, please. Now, in section 5.2 of the draft, we have elaborated on what XR performance metrics that are acceptable to the user can be considered, their operational consequences, and some pointers to operational strategies that can be adopted by network operators to achieve those metrics. This table shows a taxonomy of applications with their associated expected latencies and bandwidths. Our use case requires a round-trip latency of 20 milliseconds at most, and preferably between 7 to 15 milliseconds as discussed earlier. The required bandwidth for our use case, as we have discussed earlier, is 200 Mbps to 1000 Mbps. Next slide, please. Now let us look at the operational consequences of the desired performance metrics for XR applications such as the one proposed in our use case. Since our use case envisages multiple users running the XR applications on their devices and connected to an edge server that is closest to them, these latency and bandwidth requirements will grow linearly with the number of users. The operators should match the network provisioning to the maximum number of tourists that can be supported by a link to an edge server. Next slide, please. So we'd like to invite comments from the working group regarding the following changes that we want to incorporate in the draft. Firstly, we want to distinguish throughout the draft between the response times required by XR applications, such as our use case, and the end-to-end latency metric used by network operators. Secondly, we propose to update the numbers as per the distinction above, including stating that the latency and throughput numbers reflect the current technology. So with the chair's permission, we'd like to ask the working group if with these additional changes, is the document ready for the working group last call?
Yeah. I think first, let's see if there are any comments or questions about the content of the updates that you were outlining. Anyone? I'm not seeing anyone in the queue. And then as Renan was pointing out, our hope and expectation when we left London was that we were that close to being able to put this document to last call. So it is still a case that we think we're that close and would like to put the document to working group last call. So I would support Renan's question, basically, if with the changes as proposed on this slide, first of all, any objections to the changes as proposed on this slide or suggestions for alternative approaches? Not hearing any, not hearing much of proof of life in the room. Colin's thinking about it. Oh, there he goes.
I was going to say that I read the document. This is a moving target. This document's never going to be perfect, of course, right? And I thought the general shape and structure of, basically what it said seemed about right to me, or whatever, or close enough for last call. I don't know. I mean, I have read the document and I support it going to last call. How about that?
That's awesome. Thank you, Colin. Okay, and Chris Lemons. So with that, then I think, Renan, you have your go ahead if you want to make those changes as you've described, and then as soon as we have the updated document, then we can initiate a formal working group last call on the mailing list.
Okay, thank you very much.
Great, thank you very much. Okay. So next up is,
3DM.
yeah, Tree DN. And Lenny, I think you said you were going to present.
So just take control, Lenny, and like you did before, I've released the slides.
There we go.
Okay, can you guys hear me?
Yes,
And-
thank you.
And you can see the slides, I assume?
Yes.
Great. All right, so since last we spoke in 115, this document was adopted by the working group. Thank you. From that last draft, we added a co-author, some minor textual changes. Today, what I'd like to do is just kind of briefly review today is, what we're going to talk about today is kind of just a reminder for those who haven't read the draft or forgot what we talked about 4 months ago. Just a brief review of what it is and what it does and why it's useful. And next steps. And we'd like to hear from the working group to hear, what are the types of things we'd like to see added to folks would like to see added to this draft. So the problem statement is pretty simple. Live audience sizes are exploding. In the last few months, we've seen events with, on a weekly basis, specifically Thursday Night Football, with 12 to 13 million simultaneous viewers. Combine that with increasing bit rates, 4K, 8K, AR. And the combination of these two suggests that maybe we are at an inflection point, or if not now, will we ever be? And if the answer to either of those questions is yes, it's worth asking, well, what should we do? And that inflection point is the amount of resources consumed on the network by live mass audience events. The other thing to keep in mind is that live streaming is fundamentally different and has different, can be characterized with different demands than typical on-demand streaming. Specifically, the latency expectations are much more stringent because things like you don't want to hear your neighbors cheering or the bar cheering a minute before the the game-winning score occurs, and also things like micro betting have even tighter requirements for latency. Also, join rates are vastly different. With on-demand, it's kind of smooth, predictable. It's significant growth on over the course of an evening, but it's smooth and predictable. Whereas with live events, it can be almost like a step function as everybody tunes into the game at the same time. So there are tools to solve this problem. Network-based replication has been around for quite some time, 30 years or so. And specifically, multicast has been fairly successful in some places, and some financial networks, for example, it's absolutely vital, as well as other use cases. But for the most part, it's multicast is seen as a success only on walled garden networks. Internet multicast over the top hasn't been much a success. So it's worth noting like what went wrong, and are these the reasons it went wrong? Things didn't work out so well in the past. Are they still relevant today, or is there anything new? So it's worth going back to look at the problems with internet multicast. Kind of the three big problems are the all or nothing problem, and that is every layer 3 hop between source and destination must support multicast, which is a pretty big barrier. By the way, V6 has the same problem, and has also seen challenges in the last 30 years to ubiquitous deployment. getting every single router and firewall on the internet to support a, new routing protocols is not an easy thing. It's been perceived as way too complex, with an alphabet soup of protocols that, no one, that few people know or ever want to learn and understand. So the perceived benefit isn't worth the cost of deploying and operating the network. And then the chicken and egg problem of, there's no audience because there's no content, and there's no content because there's no audience. The good news is these challenges from the past, that there are new network replication technologies that address each of these problems. So we're kind of at a good point where, the challenges of the past and the costs of deployment have been dramatically reduced. And that's what TreeDN is. There is the components of TreeDN are not new. They've been around some time, but TreeDN is really the synthesis of these building blocks in a rather novel way. So it leverages native multicast combined with overlay to deliver multicast services to potentially anybody on the internet. So the native component or on-net is SSM based. For those not familiar, it's source-specific multicast. Vastly similar, simplifies multicast deployment. So this addresses the complexity problem. And it turns out when you switch to SSM, you eliminate, say, 90+% of the complexity and the complaints that folks had about deploying multicast. SSM, secondarily, for those parts of the network that don't support multicast, to address that all or nothing problem. Overlays, and it used to be, tunnels were, when I started in this business, tunnels were seen as a suboptimal hack to be avoided. Now all the cool kids are doing it, as long as you just call it overlays. Overlay technology allows, and specifically automatic multicast tunneling, which essentially allows the end host, think your laptop, your smartphone, your iPad, whatever, is able to dynamically build tunnels to the parts the multicast, a part of the multicast network that is multicast native, that is native. So this kind of solves that last mile problem, and the all or nothing problem, as well as the chicken and egg problem, because now all potential internet users are potential audience. And it also enables incremental deployment with these tools. Previously, like I said, it was all or nothing, but now you can deploy multicast natively, and those parts of the network that are natively deployed can enjoy the most benefits, and you just tunnel over the parts that haven't. So this is kind of a picture of what it looks like. The big I internet is the big cloud. The green part is the TreeDN provider, which is kind of a native, the native component of the network. So content goes from content provider to the to native on-net receivers, as well as to the edge of the network where there are AMT relays, and the AMT relays tunnel the content to off-net receivers. Those are receivers that are on unicast only parts of the network. How does this compare to CDNs? Some astute observers might say, well, we've kind of got CDNs. They kind of do network-based replication, except you don't need a bunch of new protocols to make it work. It just kind of works. And that's true. There's different CDN models, but a common model is you send content to these CDN boxes and they handle local receivers. How's that different with TreeDN? And with TreeDN, essentially, it's a CDN that leverages multicast. One, that AMT relay, it kind of replaces the CDN box, and it can be pushed further closer to the receivers. And content only needs to go to relays that have interested receivers. Also, it doesn't require a separate physical box. It can be a capability built into the existing network infrastructure. So specifically, routers can support AMT. And if those routers already support AMT, you can literally, think of it as CDN on a chip. You can literally deliver this traffic at zero, essentially zero CapEx if it's already, if it's available on already deployed hardware. And you could argue even zero OpEx in the fact that, you're not creating more power and space to support. So the benefits, better utilization, more efficient utilization. Not only does it make existing content scale better, but it enables new content. Question for folks, could you do AR live streaming with, say, a 5 gig stream or a 1 or 2 gig stream to tens of thousands, hundreds of thousands of viewers? Is the internet up for that? Can it handle that today? With multicast and with TreeDN, it certainly can. It scales to support that. So these are things that maybe it's just not viable economically to do it. It enables service providers to offer new services, replication as a service, again at potentially zero additional cost to deliver this service. That is, if your existing infrastructure already supports AMT. This is an open standards-based architecture with widely understood and available protocols, which is a difference than between that and say previous traditional unicast CDNs that may be leveraging proprietary technologies. It also involves far less coordination between the content provider and the CDN. Essentially, things like data storage protection, the network is just pushing packets. So all that other stuff can be pushed out of the responsibility of the network and middle boxes into something that is just handled by the content provider and the end user. So all those functions need to still exist, but it is handled between the content provider and the end user without the requirement of the intervening networks. Also, it potentially democratizes and decentralizes content sourcing. Is it healthy for the internet and society that only a handful of companies control most content distribution on the internet? Use cases, we think mostly about live streaming because that's kind of the sexiest, most interesting use case, but it's really about any traffic that needs to go to multiple destinations. So the least sexy, but perhaps most tactical use case is large file software updates, things like OS updates. Those can really crush a network when they come out. This is a way to more efficiently distribute this content that won't crush networks. So just to kind of summarize, if you look at things in terms of supply and demand, we may be hitting that point where these two, supply and demand curves are crossing where, perhaps up until now, multicast wasn't needed because live stream sizes, audience sizes weren't big enough, or bit rates weren't high enough. But with things like Thursday Night Football, and that's just kind of the tip of the iceberg. With more and more sporting events being handled, exclusively over the internet, over the top, that this may be a technology that all of a sudden you kind of actually do need it, and at the same time on the supply side, previously network-based replication was really complex and costly and difficult to operate, but those issues have been solved. So it's easier and more available than ever. And that's what TreeDN is doing. It describes a CDN model to it's optimized to handle this use case. All right, so next steps. So that's the review part. Next steps, things we'd like to add, plan to add some basic stuff. Add some diagrams. Some folks have commented that it would help provide clarity as to how these pieces work together. The biggest thing is gaps. What else is needed to deliver a useful product? Kyle kind of kicked things off with some really thoughtful comments about the missing pieces that are kind of that traditional unicast based CDNs deliver today. Most of the issues he pointed out are kind of transport issues that aren't really unique to TreeDN or multicast. They're really just more about non-TCP traffic. But that said, this delivery obviously does not support TCP, at least for the delivery of the actual content. As the draft notes, TCP sessions could be used for back channel and telemetry and bespoke advertising. But so kind of the separation of kind of the critical content, critical information, metadata is handled by unicast, but the actual interesting content that needs to be delivered, the video streams, could be handled by multicast using TreeDN. So Kyle brought up a number of issues, things like reliability and resilience, visibility. How do you know when there is loss and what to do if there is loss, and predictability of the network and what it can deliver? These are things that have been traditionally delivered. TCP helps out a lot. At the same time, while this, it's not using TCP, while this model doesn't use TCP to deliver these things, many of these capabilities can still be provided basically between the content provider and the end user. So some of this information, some of this content may be outside the scope of this document. So determining what is and isn't outside in this scope is one of the challenges we're having. Then we, as described, TreeDN is really a network technology, and there's not much to the transport side, but it is certainly what we definitely think we need to do is note all of these gaps, and perhaps call for future work to go deeper into how specifically to solve these problems. Maybe we just note what are the requirements, what are the issues, what are the things missing, and what would need to be added by a CDN provider to deliver traditional capabilities using this technology, and what's missing. So that is what we plan to add. But basically, we're looking for feedback from the working group to see, what specifically else is missing. What would you guys like to see added? And with that, I'll kind of open it up to questions.
Great, thanks. So if anybody has any questions or comments, please do get in the queue in the MeetEcho client. And somebody please have questions or comments. Okay, all right, great.
Hi, Alan Frindell from Meta. So I'm familiar with our CDN infrastructure, which is used to deliver some high-scale live events. And I think one difference is that because we use TLS, either HTTPS over TCP or QUIC, then every user has unique encryption key. And so when the traffic gets replicated out of the edge, it's not multicastable because every packet is different. So I guess maybe can you just comment on how this architecture supports encryption and or privacy?
Yeah, so this is not my area of specialty, but I'm not going to let that stop me. What I will say is there's kind of the signature company or organization that has been supporting and using and leveraging TreeDN. They presented at IETF a few IETFs ago, an organization called UMetSat, and they talked about how first it is possible to do, multicast encryption with multicast. You have to have obviously the group, a shared group encryption keys. And distributing those keys, becomes challenging. I mean, it's cable television is, essentially encrypted content that goes to many viewers, and somehow those group-based decryption does occur. So I will say it happens, and but I'm not an expert on how it works exactly. But encryption and multicast. Let me say this: encryption and multicast is certainly possible, and it is being done today.
Thanks. So I think maybe in terms of and I'm sorry, I'm not sure. I read a bunch of drafts on the plane, but I'm not sure if I read yours. But if the doc doesn't address that, it may be valuable to add text about it, because I think it will be, at least when I look at this and I think about the CPU costs that we spend, like re-encrypting every bit for every user uniquely, I mean, like, it'd be nice to save that, but then I have to have a way to solve that.
Sure.
The other question I had actually was related to adaptive bit rates and how you might envision that happening here. If we're sort of, it seems like maybe there's less control in an architecture like this, where you're live streaming and sort of just like blasting it out. And how, if you're not using TCP, how's congestion control handled? How are you responding to loss, and maybe adapting the videos that's going out over different links?
Sure. Great. Another great question. Traditionally, the way this has been done is just, different bit rates on different multicast groups. So you can, go up or down and join different groups with different bit rates. And so if you're seeing too much loss, you just join a different group that has a lower bit rate. If everything's working really well, you can jump up. So that's been one, technique and mechanism for handling adaptive bit rates, or just dealing with multiple bit rates, so that you can go up and down.
Okay, thanks.
Colin Jennings, I'm going to follow on Alan's question slightly, because we've both been thinking about this a ton, and this is very related to what's going on in the mock working group, which Alan chairs. And I think Jake Holland was talking to us about how to use multicast quick in this type of model to do the keying for exactly those types of situations. One of the other things that I think would be really worth thinking about in this, or that we've been thinking about a lot, and would be interesting to just sort of see more people thinking about it, how it would fit in, is the authorization and billing model on the CDN. Like all these, I mean, like, first of all, the fact you could do it on maybe hardware that's already there, yeah, for sure, great, like reducing the costs and stuff. But making sure, with any CDN business, you got to make sure that you've got the right identifiers in the right places to effectively bill for the usage of the CDN, and making sure that those were in place in the right way. And I know when I talk to CDN vendors today, they some of them can bill a lot for like bytes out, or that they feed out, but they also want to store for how much how much they store. And the people who are using the CDNs, like I as a consumer as an application developing on top of a CDN, we'd like to have better reliances about like hit rates and success rates, and how much data was actually cached, what data was cached, what not cached. And all of those things seem right dead center on the area of media operations. I mean, this might be a perfect place to discuss some of those things a little bit more, but it'd be neat to see some of those issues. So that was just some thoughts when I read the draft, that's all.
Sure, thanks. First, for multicast quick, a quick plug for that. There was a draft that Jake and Kyle and Max Frank we're leading, and you know, it's something that obviously would be really, really useful. You know, you know, that could be a significant answer to the question, to a lot of the questions. You know, if multicast quick, if those issues, you know, can be resolved with multicast quick. In terms of billing, you know, it's just it's a different model, but certainly just as doable. One of the nice things is there really is no storage costs, because you know you're not really caching the content and storing it. So that's one of the benefits of this architecture, is you're just pushing packets. So you don't have to really build storage complexes. But what, you know, in terms of how would you bill someone for this, you know, you can bill for example, the number of AMT tunnels that you have created. So, you know, if and there is enough accounting information in an AMT tunnel to be able to effectively bill, you know, where the tunnel is going from and to, and where it's going. And also, you know, the billing can happen between, you know, again, this is another nice benefit, that it requires less stuff and less coordination in the intervening boxes between the source and the receivers. In that, you know, the billing can happen, you know, I gave kind of a hand wavy answer on the encryption part, but you know, imagine the content provider encrypts the data. You know, anybody can join it, but they have to pay to get the decryption keys, and then they can actually view the content. Well, you know, they're setting up a, you know, a transaction directly between them and the content provider. So, so you know, that billing can happen. Again, multicast is unidirectional, but that pertains to the actual, you know, stream, the data stream. It doesn't mean that you can't use TCP sessions to set up, you know, share decryption keys, do accounting, share telemetry, you know, send back data on user experience, send back data on loss. There's how long you viewed, metering, bespoke advertising. So you know, unicast can still deliver many of the things that unicast does. TCP gives you today, just kind of out of band and in band. You know, the signal can be handled with multicast far more efficiently.
Okay, thanks. I've locked the queue after Jordy, and at that point, I think we'll go to addressing your specific questions.
Hello, Jordi Sansano. I have a question about what you are proposing. So basically, the current in online video, the protocols that we are using today, as far as I know, they are reliable. So basically, in the engines, we use RTMP, for instance, that is based on TCP. On the egress, HLS or Dash, that is based on HTTP, so TCP. But now you are proposing multicast. And in multicast, we can drop packets. You can add FEC, so you can correct some of them. But at the end of the day, that protocol will be unreliable. So you are basically, if I'm, and correct me if I'm wrong, you are asking the players or the relays to handle an unreliable, or to survive, better said, to an unreliable stream. So is that correct? Is my understanding right?
Yes, you know, it's not using TCP, so you know, it's using UDP. UDP is unreliable. So then things like, you know, norm and forward error correction can be utilized to, you know, deliver, you know, deal with packet loss and reliability issues. I will say this, you know, that what you're asking and is not about multicast, it's about UDP, and how can a service be delivered with UDP. The one thing I can say is, you know, I'm not an expert, but I do know that there are companies using UDP to deliver live stream content.
I don't know. Yes, it can be done, but sorry.
Yeah, sure.
No. My point is that it can be done, but it seems that it's a big leap. So for some players,
It is.
change from reliable to an unreliable paradigm, it's not easy.
Yeah, I mean,
I think that
there's no getting
actually, I
around
think that actually goes, but I think that actually goes to the heart of where, your questions, Lenny, about what is appropriate in this doc and what can be future work. Because
Right.
what I wanted to say there was that I think the real value here is in describing the challenges with things like, real-time video, real-time delivery of events, not stored streaming. Sorry, the jet lag is just hitting. So I think that using this document to focus on here is a real problem that isn't really addressed by either of the sort of top approaches, multicast or, CDNs up the wazoo right now. And here is a way of looking at how to address it at a sort of at an architectural level with some pointers to possible technologies to implement it, but stopping short of saying this is the protocol and this is how you do it. The reason that I suggest that and why I tied into your question, Jordy, is because then it's not a recommendation that service providers would move to an unreliable transport for video, but rather if you discover that this is the situation in which you find yourself, where you have this kind of video to deliver and you don't have any other choices, this is what we know can be done today. Here's a choice. Not a recommendation, it's an observation. So.
Yeah, I think that's, Leslie, I think you've described it very well, and Jordy, thanks for pointing that out as well. What there is a cost, if you're going to lose the inherent reliability that TCP gives you, but you're gaining something, and that is vastly more efficient utilization of the network. And again, tens of millions of viewers of, say, 4K streams. You can do it with brute force unicast. We've been doing it with brute force unicast, but how much further can you go? How far can brute force unicast go? What about a world with AR live streaming with tens of thousands of viewers and millions of viewers? Yes, TCP gives you lots of nice things, but at some point, can the network handle that? So that's where network-based replication, gives you something, even though you're losing things like reliability, but the benefits outweigh the costs. And Leslie, I think that's a great point. I think, what we'd like to do is start kind of listing all these gaps, what's different, what's missing, what needs to be taken account for, and not necessarily, and it's kind of like requirements, and not necessarily say, here's the solutions, but just here are the, because, my fear is even if we did know what the hell we were talking about for these solutions, they may be obsolete, or there may be much better techniques, and we don't want to, say this is the way to do something. We want to leave room for providers and operators to come up with their own innovation. But we'd like to point out to, here are the problems you want to solve, and, stop short of saying, and here's how we think you should solve it.
Right, with maybe some illustrations of this is one way to approach it, but it may not be the best way, just as illustrations.
Sure, absolutely.
So does that give you enough sense of direction for sort of where to go next with the document, or?
It does, yeah. This definitely does help. I would encourage everybody else, everyone, we would love more feedback and thoughts and comments and ideas. Encourage. Please do read the draft. It's short. It's short, readable, and it's written for people who don't know multicast. If you don't know anything about multicast, and you want to learn how to use this to build a hopefully usable service, this is what it's written for. So if it's not, or that was the intention. So if you don't find it to be accessible and understandable, please let us know. We'd love any and all feedback and any and all suggestions as to what are those gaps. But we'll start working on it, and we'll present. We'd love to present in 117 on what we've added.
Great. Thank you very much. All right, and everybody, as you heard Lenny ask, please do read the draft and provide feedback. Okay, then we will move on. Do you want me to drive the slides, or you can drive them from your phone? Or are you just going to do it from here?
You drive them, I'll stand up there.
Okay.
You want to do it on your computer?
No.
Push the button on mic?
Yeah.
There you go.
All righty.
There's a giant pink X to stand on up here. It's awesome. Hey, I'm Glenn Dean, and I'm going to sort of switch hats here. So I'm the MOPS technical advisor. One of the things that means that I try to do is bring industry perspective into MOPS. And so that as we construct agendas and try to get people to talk here, we try to make that connection, because the world is full of video, and there's a lot of groups outside the IETF that are working on video. And one of them is SVTA, and I'm here to talk to you today, as I often do at IETF meetings, on connecting the work that's going on in SVTA. And part of the reason we do that is that SVTA takes stuff that the IETF produces, adds some secret sauce, adds some public sauce, adds some extra work to it, rounds it out. Kind of the stuff like Cullen was pointing out of, hey, wouldn't it be really cool if we talked about how you take the CDN stuff and add all the business gorp around it to make it deployable to do business work? That's what the SVTA does with IETF stuff. It also takes practical experiences from operators and brings it back to the IETF. And so over time, we've seen a lot of cross-pollination between the two groups, and growing cross-pollination between the two groups. And it's going to get even better. I'll show you that in a minute. Next slide, please. So in case you haven't heard, SVTA added a T to their name. They used to be the SVA, and then we added T for technology, so that's cooler than just having SVA. So this is, we became even cooler with the added T. Next slide, please. So what is the SVTA, if you don't already know? First of all, it's 100 plus member companies and growing. If you go look at that link, you may just find your company is one of the members of the SVTA and growing. Microsoft just joined. So if you work for Microsoft, welcome to the SVTA. If you wanted to understand what the group does, really you could sort of say it's like an operators group. It's not quite an accurate description, but it is for video what a group like maybe like Nanog would be for networking. We take IETF specs, wrap stuff around them, do extra work, feed requirements back into the IETF, but also deploy them. And then create best practices, specification documents, APIs, interface control things in the documents, and then publish them. So it's sort of like a turning what goes on here into production stuff that people can make use of. And those are the working groups we have open today. Open caching, obviously, is a pretty big one. That's built upon CDNI. We have a metadata working group, live streaming, which is AK for low latency stuff. Networking and transport. I happen to chair that group over at the IETF, or sorry, SVTA. Privacy and protection, that's security stuff, right? And privacy. Edge storage, players and playback. Mr. Began here is involved in that. I should point out Sanjay at the back there is the coach, one of the involved with the open caching stuff. CDNI over here and open caching over there. Immersive video, measurement QE, and advertising. And there's always new groups spinning up. Next slide, please. So I wanted to point out a couple of key projects that I think that there's really great connection points with the people in this room and the broader IETF that you may want to take a look at and be aware of, especially if you're a member company. And then the work going on back here at the IETF. For instance, earlier today, if you're over in CDNI, there was presentations from SVTA about SVTA proposals and drafts that were coming back over to the IETF. So that's how the relationship works. So obviously open caching, and you can find out more there. There's a project going on investigating approaches to multi-CDN delivery. Mr. Began here is one of the chairs chasing that one. And there's a link there, you can find out more detail. There's the group I chair is working on a quick POC. This is an interesting one. It's not what you might think. This is not a bake-off of quick versus not quick. This is solving a practical problem that, you know, there's been a lot of great work done in the IETF around quick, but there is a lot of challenges for operators of CDNs, players, and other tool environments to adopt QUIC as their delivery pathway. Part of the problem is that they've got a lot of guys very skilled in TCP architecture, not so skilled in QUIC architecture. And if you start talking to them on sort of a high level, they can get a little glazed over. There's so much change here, I don't even know where to start. This project is defining a reference test environment so people know how to assemble the pieces. How do you build telemetry? How do you collect network and player telemetry? And how do you reconcile all that information to answer basic questions like, if I build out a QUIC architecture, will it perform as well as my existing TCP architecture? And how do I measure that? That's what that QUIC POC is for. And there's publications, and there's more and more publications going to be coming out from that one as we proceed. There's distributed ray tracing, which is essentially the question of, sorry, did I say ray tracing? My gosh, my old days of graphics guy. Distributed tracing, where the challenge is when you deploy architectures end to end, how do you know they're working? How do you determine where the problems are, and how do you go fix them when they do happen? This is not the world of closed end-to-end delivery that you had in other environments. This is over the open internet, and things go bump that you can't see. How do you discover those, and how do you follow them up? That's what that work is doing. And then lastly, there's a new project that's just kicking off, and that is starting to document from a video delivery perspective all the crazy stuff that is done in the DNS to make that work. And it's not meant to be judgmental, but there probably will be things that get called out as, this is a good idea, this is a really bad idea to do in DNS. And we know people do really funky things in DNS, so there's going to be some good stuff to talk about there. But if you care about DNS and you care about video delivery, you might want to get involved in this project. Next slide, please. Okay, so how do you get involved? Obviously, if you're a member company, join up. And if you can't find who your rep is, come talk to me or talk to Sanjay. The emails are at the very last part of here. We'll connect you. But there's a couple things I want to point out. There is a conference, a brand new industry conference called Segments. Never happened before. It was supposed to happen just before COVID started. That got interrupted and delayed a couple of years. But we're now having it May 16th in New Orleans. So if you're in the area, this is a public conference. You don't have to be an SVTA member. You can come, you can join. It's open to everybody. It's going to be all around streaming, delivery, B2C type environments. And it's going to be a great conference. Please come join. Again, open to the public. Don't have to be involved with the SVTA or a member of the SVTA. Following right after that for SVTA members is the Spring 23 conference in New Orleans as well, May 17th to 18th. And then here's the really big one. In the fall, guess who's going to Prague? The SVTA is going to Prague the days right ahead of the IETF. So this will be a great opportunity for the two groups to co-mingle and interact with one another. If you want to find out more information, if you're not a member, you want to come participate, give me a shout. We'll see if we can hook you up. But so I think IETF starts on Saturday. This runs the week just a couple days ahead of it. So come a little bit early. Come see what the SVTA is doing. Stick around for the IETF. And we're going to say the same pitch in reverse. The SVTA members come for the SVTA, but stick around for the IETF. Next slide, please. So how do you contact me? There's my contact information. I'm Glenn D at Comcast. Sanjay, back there raising his hand. You can contact him for information. Everybody knows Ali, so you can contact Ali. And Jason, JT, is the executive director. He's sort of RJ. You can contact him. He's a very friendly guy. And with that, I'll take any questions you guys want to field to me.
So while people are putting their hands up, I have a question or an observation. In particular, the work that you referenced about the DNS, use of the DNS and video delivery, it occurs to me that that will be a useful thing to bring back here and talk about. Because I mean, generally here in, well, specifically here in MOPS and generally here in the IETF, because as people consider new options to bend, fold, spindle, and mutilate the use of DNS, it might provide some insight into what it might trip up.
Yeah, no, we absolutely will do that. That is exactly the kind of thing we'll bring back here and point people to and present on. And then people say, well, oh gosh, don't do that in the DNS. And you'll probably be right, because people do very bad things in the DNS. I mean, somebody once told me you aren't really an IETF until what? Until you've proposed putting something in that lovely global database that is the DNS. And then you
I
are
am
truly a
not-
true IETF where you go, oh, that was a terrible idea. Why did I ever propose that?
I am so not going to respond to that. Great. Any other comments or questions?
All right, well, if there's no questions, thank you very much.
Thank you. All right, Colin.
You gonna drive?
Okay. Thank you. I'm going to be talking about a little bit about a project we've been doing around hologram and some of the holograms and some of the experiences we have with that and where we are on that. So can you bring up slides for me? Thank you. Excellent. Awesome.
Oh, change the order. Hang on.
So as a bit of background context, we've been working on, there's a product that's I've been working on for, I don't know, roughly 5 years or so. Noir, there are a bunch of other people in the room here have been involved with it as well. That is about delivering a AR VR hologram experience. I'm going to talk a little bit about some of the things we've run into as we've done that. And then a little bit about what it is and what about the sort of network bandwidths we've ended up using. So it sort of ironically sort of fits like right into the context of the draft that we were talking about earlier in the meeting. Awesome. Next slide. So the idea of this system, when you use it, there's a camera array that's capturing a light field of a person that's being recorded. So on the figure out it's my right or your right here. Yeah, on my right, there's a person who's like presenting something, that object's being captured, they're being captured. The person on the far end is wearing an AR headset, and they're seeing that person projected as a hologram across the room from them, and it'll show us a few images and bits and pieces from it in there. So next slide. So that's the basic context of what we're working in here. So the capture device, again, is a bunch of cameras. We're primarily using light fields. I'll talk about a couple of different media types later that I think are important to this space that we should be thinking about. And that's streaming up to cloud service, AWS in this case. It's about a 30 megabit per second stream that's going up with that light field. That's in the cloud. We're splitting up and pre-rendering it partially into the headsets, and I'll talk about some of the latency aspects of that in a second. And we're sending them down about a 6 megabit stream to each individual headset. And then on the headsets, we'll do some additional computation, particularly to compensate so that when you rotate your head, everything that you need to compute the new image is right there, okay? But when you sort of move your head a bunch sideways, I shouldn't move away from the mic, then you need some more information from the cloud from a different viewpoint, and that will get updated at a slower timeline. So next slide here, please. Over the longer term, of course, we'd like to be able to use things like what's going on in Mock or CDN trees, these types of ideas. We've talked about all of those sort of types of ideas in the future, but we're not doing any of that right now. But we'd like to be able to push this out to a 5G, low compute edge, and all the things that this working group's talked about over the years of getting that light field processing closer, less latency between the headset and that towards the edge, and then also just ways to raise the bandwidth between the headset and the edge of that cloud. Pretty much, as you get your bandwidths go up, your fidelity of these experiences can go up. That's pretty obvious. As you get your latencies down, it gets better experience too. Okay, next slide. So I want to talk about latencies a little bit. The sort of primary metric of all these systems should probably be time till you feel like you're about to throw up. And there's a lot of things that factor into that. It's not just latency of view updates. That's one of the things. But on early systems where you have bugs in the code or something where you're not compensating for what your brain thinks it should be seeing in the correct way, you get these motion sickness type issues. And so the latency can be fine and you can still have a crappy experience or an experience like that. But when you get all of these things right, people and now at this point in our system, people will go for a long time and they're perfectly happy using it. They don't have those feelings at all. And it was a bunch of things to bring that together. So one thing about it is definitely when you turn your head, how fast you need to update. And I mean, it's probably more like 7 milliseconds or something. It's certainly it's in the under 10 milliseconds, as sort of order of magnitude. That needs to be quite fast. And we're finding that, a lot of the things, your brain wants that to update very quickly. And your brain is dealing with, different parts of your brain are dealing with this at different speeds. So part of your brain might be willing to accept that the model of the world only updated, but your peripheral vision that's quite fast might just say, no, something's not right here. So you need all of that to be fast. Now, the parallax issue, when I shift like this, if I move sideways and everything in the room that's behind or in front of other things sort of moves a little bit, that latency, on our experience, has been that latency can be a fair amount higher. We don't necessarily always correct that exactly right until we have a round trip back up to the cloud and down again, which is way over 10 milliseconds. Okay, and so I think that when you start seeing these metrics of this, you need to start splitting them up of what needs to be there and what's not. So the other thing too is, and you know, it's one of these things I've been interactive and live too. The whole thing's about it is, you know, interactive is not an exact number of milliseconds. It's very much a feeling that you're not in a turn-taking experience, that you can just talk to somebody and they can answer and they can interrupt and break into the conversation. So maybe it's like less than 300 milliseconds for some type of use cases. Maybe it's different for other use cases. It depends on the context, what the actual milliseconds is. But interactive is that type of feeling. And live is that feeling that even though you're not interacting with it, you're seeing it as it happens. And so that could be much higher depending on the context, or much lower depending on what other surround context you have, like people cheering at the stadium as you're seeing things, right? But live goes down to 0, I think, is one of the important things. This is a live conversation we're having right now. It's not like live has a lower bound. Live's lower bound is 0. And I think that those are all important to understand about these, is that these interactive and live are very much a user experience more than an exact number. And you need to think about them that way when you're trying to design these systems. So let me jump to the next slide here. A couple different approaches we've seen in all of these AR VR systems, and that we've played with ourselves at various times. One's texture map polygons. This is the easiest one that you see lots of people start with. It's great for objects. You can take all the technology that came out of game development and our current rendering engines to do polygons and texture maps on them. That shoe right there was scanned with the Apple software for scanning things. It doesn't really get fine detail very well. And one of the problems with it is on the real time, if you're trying to scan this and form these models interactively in real time, a lot of the problems that we see with these systems is if you get a single point wrong, like a single point on my shirt scanned wrong and its depth's way off, I will have this spike that's protruding out of me, okay? And so a single piece of noise in your data creates a huge visual artifact. And that's really, you keep feeling like, oh, I'll be able to filter that noise away, get rid of it, but it's hard. So that's one of the issues of these systems. Next slide. Another system we see a lot is point clouds. I think it was mentioned earlier today in this meeting. So the point clouds are, you've got an incredible number of points that each are represented by a color, and if you have and you know where they are in 3D, and if you have a dense enough cloud of them, it turns into looking a solid object. Typically, these systems are a little bit easier to hide the noise. If you have a point that's just wrong, it's like a speck of dust somewhere, it's less noticeable, less visual artifacts, and you can get down to a little bit finer resolution. We've seen systems using those. Next slide. I'm going to explain a little bit what light field is. The light field idea is simply that if you could capture every ray of light in this room, like every ray of light through every point in every direction, and take that function and be able to send it to the far side, then you could easily synthesize any viewpoint from there. Now, of course, you can't do that. You have to do some approximation to that function and how good it is and what volume you could capture over and stuff. But one of the things that's nice about this is it really starts to capture that the image looks different from different viewpoints. So if you look at these two images of the orange, that's under the same lighting conditions. It's just shot, the heads move from one position to another. And it's looking at the orange from a different viewpoint. And you can see the specular near the X on the orange has totally moved. And all the reflections move and everything else. And you might think, oh, that doesn't really matter. People aren't shiny. But people are shiny. All of our skin is shiny. We have a very reflective looks on that. And so it's important to get this type of stuff right. And we think that if you want a really photorealistic version of what people look like, you need to sort of do that. So next slide. So this image is shot from inside a headset that's representative of like what type. I mean, it's impossible to show what this looks like without you actually putting a headset on, right? Otherwise, I'd be demoing it here. But this is an image that is shot from inside a headset that gives you representative of what the hologram looks like of Aaron here, the person standing there, and then the room behind him. Now, I think a part that I always like to look on this is just like how the water looks like, and the fact you can see the shirt through the water and those types of things. That'd be very difficult to do with a point cloud, very difficult to do with texture map polygons. So it's one of the appeals to me of light fields for this type of approach. So next slide. And next slide. That's just some comparisons of those three techniques. We're not doing this yet, but I'm sort of really, I think that these NERFs are really probably going to be one of the most interesting things going forward. They can represent the same type of thing as the light fields, but with far less cameras capturing less rays of light, and they can do it with a lot less information. They can synthesize really high quality images. Today, the ones that I'm seeing aren't really at the computation speed that we could use for real time, but anytime like something looks great, but it's too slow, like, I don't know, drink beer until it's faster. I don't know. I think this is one of the hot areas that are coming and that we should be thinking about from a media point of view. Next slide. We also have medias in this that are not about the video. So a lot of these systems use a toolkit from Microsoft for recognizing where your hand is and all the gestures and information, this MRTK toolkit. But whatever it is, you're probably interacting with this AR, VR experience, and you're often using gestures or something else to do that. And you need some way to map those types of objects into the system and send them to the far side too. And if you are using some virtual objects in your environment and picking it up and moving it or whatever you're doing with it, you need ways to represent those types of things too. So there's a draft that myself and another person have been working on a little bit. Maybe it's the right thing or the wrong thing, but we need some ideas for how to represent that type of information into these systems as well for the AR, VR systems. Next slide. And so this is my really last slide. I think that I'm happy to answer any questions about sort of our system, what our experiences with it that might impact or guide other systems or give information to this group about how we're running it or things we've run into. I do think that we ought to be thinking about media types beyond the sort of traditional video into other types. And I think that we're talking, I think there's lots of ideas as the volumes of this data goes up of looking at ways where you can seamlessly move the compute and latency closer to the edge without having to re-architect or redo your whole system, how you can move this over different things. I think MOC is, plays into some of this as well, those types of things. So I think it's a really interesting time in this space right now as you see all kinds of proposals going in the same direction, whether it was a treaty in, whether it's the MOC working group, where there's some stuff outside of IETF. There's a lot of people thinking about how to have a much better media distribution right now, particularly for these distributed things. And part of what's driving that is the streaming latencies are trying to move to be less. If you look at anybody who's delivering a streaming media service, the more they can make it interactive and bring viewers content and stuff, it really connects to the stickiness. So there's a lot of driving to pull those latencies down. On the flip side, all the people that do the real-time type stuff of the Zooms, WebExes of the world, Microsoft Teams, those are scaling up to hundreds of participants, and they're wishing they're scaled up to hundreds of thousands of participants, right? So there's all of that converging together, and I think that makes it an interesting time in this space. So with that, let me just stop there and see if people have any questions or other bits and pieces they want to add in.
So while people are getting in the queue, I'll just observe that what you're saying, at least in part, is that everything we've discussed in terms of challenges for video delivery, et cetera, is sort of geometrically expanded when you get to VR, and the consequences are potentially worse insofar as our physiological reactions if we don't get the latency.
Yeah. I mean, like your lip sync's bad on a WebEx call, you don't want to throw up. Right? You might be like, oh, that looks stupid, but it doesn't have that same sort of reaction. So it escalates that on that access, escalates on the complexity of doing it. But on the other hand, it's, in my mind, we're doing it on today's networks today. Like I can run this on LTE, like it's 30 megabits per second. It's not like we can't do this until we get to 6G. Right. We can do this today on today's networks.
Very cool.
Cool. Well, thank you.
Anyone want to make a play for a question or a comment? Oh, here we go. Go ahead.
Thanks, Colin, for that presentation. I just had a question regarding implications for codecs. Do you use existing codecs, or do they need to be adapted to whatever technology you're using?
I mean, We do leverage existing codecs, and it's, I mean, how we use them might be a little bit weird of the sort of meta information that tags alongside with them, but this system as we have it deployed today is largely running on H.264 as the baseline codec for it. And, you know, Mo in the room here is like one of the key people to talk to about that, but we very much would like to take advantage of some of the tools that are in AV1 as soon as we can and move to that. It offers some possibilities that improve things. I think that there's been lots of thinking about how to design a next generation codecs that are specifically for volumetric video in various forms as well too. We're not taking advantage of any of that stuff yet, but certainly that, you know, every one of these things can help this problem.
Great, thanks.
All right, thank you,
Thank you.
Colin. Alan, if you'll come on up. People here may recall that when the MOC working group was being formed, there was some discussion about, you know, sort of relationship to MOPS, et cetera. And I know the MOC working group has been very busy over since we all last met in London. So thank you, Alan, for coming and giving us an update on what's going on in MOC.
Sure, thanks. I think it's going to be tough to follow Cullen's presentation. That was really cool. I do not have any holograms or like cool metrics like time to puke. But I am Alan Frindell. I work at Meta. I'm one of the MOC co-chairs. I'll give you an update on MOC. Next slide. So just a high level, like what are we doing over in MOC? If you didn't know, these are kind of a summary of Ted's words, but the goal of MOC is to build protocols needed for real-time or near real-time media that leverage QUIC for its best advantage. You know, there's a ton of motivation, discussion that went into, we had 2 BOFs last year. So I'm not going to rehash it here, but we were chartered, working group was formed. Our first full meeting as a working group was in London. And since then, we've had in-person 2-day interim in Seattle and another virtual interim a few weeks ago. So I'll give you a kind of an update of what's happening and where we're going. Next slide, please. So we spent a lot of time trying to understand the problem and also understanding each other. A lot of different use cases came to MOC, people with specific applications in mind that were very different. And we spent a lot of time learning. What is it, you know, what's live video ingest look like? What's live video distribution look like? What does web conferencing look like? And that's led us to trying to come up with some terminology that we can all work with. And we think we made progress there as well, like having just terminology vocabulary that we can use to have these discussions. And we've talked about requirements, and we are actually agreeing on some, maybe not all, but we're getting there. There's a requirements draft that started last year as part of the BOF process that's around. There's a new scenarios draft that was published earlier this month. We're going to be talking about this week. I think it does a really good job going into detail about some of these use cases and looking at similarity and differences specifically as they apply to MOC. So check those out. Next slide. There's been some very nice experimentation going on. So at our interim in Seattle, we had a few different presentations, people showing tools they built that are a lot of them using web codecs and web transport in browsers to send media over QUIC in new ways, not just HTTP3. And those were all really cool demos. There's a new one that just came out. It's going to be presented this week. So you can follow these links and check out some of this code if you're interested in playing around with that. I've heard good feedback. So, and this is going to help inform the working group's decisions, right? Like having running code and real data. It's going to be good. Next slide. You know, and so we're building the beginnings of a solution here. So if you remember MOC before it was formed, there were 3 input drafts that came from different places. What we did is we took the authors of all these drafts, we like made a superstar all-star team and said, here you guys go, like write a base protocol. There's a draft there. It's been under several, I think just published revision 4. So there's been a lot of back and forth on it. There's a very active GitHub repo. And really the working group's trying to get to a place where we can adopt a baseline, which is going to be the beginning, not the end. And we'll continue iterating on it over time. A second base protocol draft was published this month. and I spent a lot of time on the plane reading drafts. I read all the drafts carefully. I don't find them to be so far apart in a lot of fundamental ways, which I think is good. But we will be discussing the deltas on Thursday. Bring your popcorn. Next slide. So the trajectory of the group? Where are we going? So the requirements draft actually went out for an adoption call just I think Sunday maybe. So it's running for a little bit. So welcome your feedback there. And my co-chair and I were really hoping that after this set of meetings this week, we hope to make a lot of progress, that we will be in a place where we cannot issue an adoption call. We don't expect that whatever document we have is going to have full working group consensus on every issue as it gets adopted into the working group process. But we just want to make sure we identify clearly, like, these are the areas where we know we still need to work, and then we'll know that we're going to continue driving towards consensus on those issues. But after adoption, I think it does unlock, instead of having a bunch of different demos running, like, we can try interoperating. We can have 2 different implementations trying to send media over quick from one to another. And hopefully we can demonstrate that the single protocol can meet more than one use case, which is, I'm looking forward to it. And there's probably more interims in our future. The group, I think, really needs high bandwidth at this stage. There's a lot of great discussion going on the mailing list and in several GitHub repos, but these high bandwidth conversations, I think, really important for where we are right now. And I know it's a lot, but anyway, we welcome the participation. Next. So this week, where can you find us? So Thursday, 1300, and the very last slot of IETF, Friday at noon. We know you guys are all staying around to come to see Mock, and I'll make a separate plug. As much like MOPS struggles with finding note takers, we are also struggling. So, but we brought chocolate. So come on over. You can volunteer in Mock. You should.
Sure, show us up.
If you were thinking about taking notes in another session, just save it for Thursday. Okay, that's enough. I hope you see you guys there. And I think with that, just anybody have general questions about things that are going on in Mock that I can answer here? Happy to.
Anybody online? And while people are reaching for the buttons, I'll just take the opportunity to thank you for coming and sharing that, and suggest to everybody that, particularly now that you know what it's all about, please do get involved in the mock work. And particularly if you have your own set of experiences in video delivery and business requirements for video delivery, definitely get involved in mock.
Yeah, absolutely. I would say particularly maybe those requirements or scenarios drafts would be a great place to jump in if you haven't seen any mock work, and see if that lines up with your real world experience. It's valuable feedback for us.
Great.
All right.
Great.
Thanks, everybody.
Thank you. All right. So that's the end of our formal agenda, unless there's any other business. If anybody has anything else they feel the need to bring up at this time. Going once. Going twice. Launch. Thank you, everybody. And thanks again to Ali for taking notes.
Hello. Anything special with this, or it's just over this? I share the link.
Oh yeah, yeah, it's good. Thanks. There is one. There is.
It's all the same, right?
Yeah, I believe so. You made a new document.
Yeah, I made a new
Okay, so there's one that's linked to the. So I'm gonna take everything you did and I'm gonna copy it.
I tried to look at it, and there was something there. When I looked at it, it created an image.
Okay, all right. Well, I'm gonna copy it over just so that I don't get yelled at by the secretary. But yeah, actually, I will copy it over and I'll tell you that I mean, technically, management said I was not allowed to come. That was the official word, but it's whatever. They said I'm allowed to have a vacation in Japan. So. Okay.